Okay, so now we're talking, still in section 6.2, about relative maximums and minimums and how to find the zeros given your factors, okay? And so a maximum is the greatest y value on the graph, a maximum. So the greatest y value on the graph. So remember, the maximum point is the highest point on the graph. And so this is the highest y value on the graph. I don't include the y value that would be at where the arrow ends, because the arrow is not going to end. It's going to continue to go on and on and on indefinitely, and we would not be able to name a highest point. So instead, we name what we know to be a definite maximum on the graph. So the greatest y value on the graph. 4 is the highest value. Okay, that's your maximum. Okay, and then the minimum is the lowest y value on the graph. So this would be your minimum, and so that would be at -3. We call those the max and the min. We always shorten everything. So the maximum values and the minimum values. So at times we'll be asking you, what is the maximum value of this graph? What is the relative minimum value? It's relative because we don't really truly know where those arrows will, if they ever end. So we just call it the relative maximum, so the one we can find essentially. Factors and zeros of a polynomial function. All right. So we use the factors to find the zeros. We did this with our quadratics when we were trying to graph our quadratics. So finding zeros or x-intercepts when in factored form. So you're going to use the zero product property. Use the zero product property. Now we've talked about the zero product property before, and it says that if you have two parentheses and you have some values in here, let's say it's x plus 2 and x minus 3, and the answer is 0, then you know that this one has to equal 0, or this one has to equal 0, or they both have to equal 0. And so when we were dealing with our quadratics, remember, we just set each of those equal to 0, and then we solved. And we found out that when x was -2, that first set of parentheses would be a 0, and we would get 0 as an answer, so that makes the sentence true. And then we did x minus 3 equals 0, and we solved, and we got x equals 3. So we knew that if we put 3 in here, that one would be 0, and we would again, that would make the sentence true. We would get 0 as an answer. And then we know that both of them, since they both make the sentence true, are both zeros of the function. So this is called the zero product property. So we're going to use that knowledge to help us solve for the zeros of our polynomial. So we have three factors, x minus 2, x plus 1, x plus 3. I know that many of you can right now tell me that the factors are +2, -1, and -3, because you've gotten really keen at noticing that if this is a +2, then we would have to get a -2 for them to equal 0. And that if this is a -3, then we would have to get a +3 for them to equal 0. So you've gotten really good at figuring out that they just need to be the opposite. What I do want you to make sure that you understand, though, is how we get those numbers in case they're not as simple as x minus 2. Sometimes they're like 3x minus 7, and you would have to do a little bit more work. So essentially what we're doing is setting every one of these equal to 0 and solving. Subtract 3, x equals -3, check. Subtract 1, x equals -1, check. And add 2, x equals 2, check. So these are your three roots. That means that this is a cubic, and it's crossing at 2, -1, and -3. So it's going to be something like that, right, if we wanted to try to sketch it. So again, let's find the roots here. X minus 7 equals 0, x minus 5 equals 0, x minus 3 equals 0, Add 3, we get x equals 3. Add 5, x equals 5. Add 7, x equals 7. Again, negative 7 here, positive 7 here, negative 5 here, positive 5 here, negative 3 here, positive 3 here. Okay? All right, so using zeros to find factors and write the polynomial in standard form. So now what we're going to do is, if I tell you what the zeros of the function are, you ought to be able to go all the way backwards, write it in factored form, multiply it out, and then tell me what the original polynomial function was. So remember, we would start with this big long polynomial function. We would break it down into its factors. We would set the factors equal to 0 and be able to tell what the roots were. Now I'm saying, I'm going to give you the root. I want you to write it in factored form, and then I want you to multiply it all out and tell me, what is this polynomial? So we're doing this completely backward. When you're done, you're going to have a polynomial in standard form. Here are some things you need to remember about your factors. When you're finding the factors from the zeros, you're using the factor theorem, which says that your factor x minus a is, sorry, I need to fix that, where a is a non-zero number. Okay, a is a non-zero number. So a is, I'm sorry, I didn't mean to write non-zero number. I meant to write a is a 0. So we're trying to figure out what the 0 is. What is this 0 that we get here? So we're going to work backward. Okay, so when we had x minus a, that was the same thing as x minus a, and a was positive. Okay? But when it was x plus a, that means that it had said x minus negative a, because subtracting a negative turns that into a positive. So when x is x plus a, then a was negative. So this goes back to the thing we were just saying, that when you have x plus 2 in the parentheses, it's going to be negative 2, right? And when you had x minus 3 in the parentheses, it was positive 3. So if I give you these roots, negative 2, positive 3, and another positive 3, then what you need to know is that when you're plugging them back into the parentheses, it's going to be x minus negative 2, and x minus 3, and x minus 3. So this subtracted negative 2 is going to be x plus 2, x minus 3, and x minus 3. Okay? So you have to remember that when you're plugging it in, that you're putting in the opposite sign. Negative 2 is a positive 2. Positive 3 is a negative 3. Positive 3, negative 3. Okay, please be very aware that when you put them back into the parentheses, you have to take into consideration the factor theorem and the fact that it's going to be backwards. Okay? So now that they're in their parentheses, it's just a matter of doing what we did in the other lesson, which is taking it from its factored form back to its standard form. So we're going to FOIL out the last two items. X squared, so negative 3x and negative 3x gives me negative 6x. Negative times a negative is a positive. 3 times 3 is 9. So I have FOILed out x minus 3 times x minus 3. And now, in red, I'm going to distribute my x to everything. So x to the third minus 6x squared plus 9x. And then in blue, I'm going to distribute the 2 to everything. So plus 2x squared minus 12x plus 18 equals 0. And then we take a few minutes and we combine our like terms. So x to the third minus 4x squared minus 3x plus 18 equals 0. There is my polynomial in standard form. So we started off with the roots, we put them back into their factored form, we multiplied out the factored form, and we are right back to the very beginning with our polynomial. At the top of the next page, there's another example for you to try. I want you to go ahead and take a minute, maybe pause the video, try that one, see what you get for an answer, and then go ahead and play the video so that you can see how, in fact, it worked. I'm going to scroll the page up, and then I'm going to do the problem. So if you want to take a moment and try it, then you should pause now. Otherwise, we're just going to move right on and do this problem. So remember, I'm going to put my roots into my parentheses, so I'm always going to have x minus, and x minus. And then these blank spaces are where I go ahead and put my roots. Those are where my a's go, right? This is like A, and A. So x minus negative 4, x minus negative 2, and x minus 1. Then I have to fix all my, subtract the negatives. So x plus 4, x plus 2, and x minus 1. Some of you might have been able to start right at that step, just knowing that you need to make these be the opposite signs when you plug them in. And if you can do that, that's fine. Let's FOIL out the second two. So I'm going to leave my x plus 4 out in the front. X squared. Outside is negative x. Inside is positive 2. So 2x minus 1x is x. Positive 2 times negative 1 is negative 2. Okay. Then I need to distribute my x plus 4. So I'm going to distribute my x to everything. Gives me x to the third plus x squared minus 2x. Then I'm going to use the 4 and distribute to everything. So 4x squared plus 4x minus 8 equals 0. Combine all my like terms and write my equation in standard form. X to the third plus 5x squared plus 2x minus 8 equals 0. There is my polynomial in standard form. Okay? So the factor theorem helps relate 4 key facts about polynomials. These facts are equivalent. That is, if you know one of them, you know them all. So if you know negative 4 is a solution of x squared plus 3x minus 4 equals 0. If you know, you can know that negative 4 is an x-intercept of x squared plus 3x minus 4 equals 0. Negative 4 is a 0 of the equation y equals x squared plus 3x minus 4. And x plus 4 is a factor of x squared plus 3x minus 4. So what they're saying here with the factor theorem is that you know a whole lot of information about an equation if you know one of its roots. So, for example, they just told you that one of the roots was equal to negative 4. And so just by knowing that you know that negative 4 is a solution, because we know that my equation, my graph, is going to cross here at negative 4. That's what a root is. I know that I have an x-intercept, right, because it's crossing the x-axis at this point. If I know that it's a root, I know that it's 0, because a root, an x-intercept, a solution right, is 0. These are all exactly the same thing. And I also know that I have the factor x plus 4, right, because I know that that root comes from that factor. So just by knowing one root, I have a 0, an x-intercept, I have a solution, and I know a factor. So it's a lot of information you can get from one tiny little piece